Good morning all. Myself is Vigneshwari, Assistant Professor in the Department of Electronics and Communication Engineering from SNS College of Technology, Coimbatore. So today I am going to discuss on the topic breakdown in transistor. So kindly watch my previous videos on the transistor configuration. So this comes under the subject basic electrical and electronic circuits. So let's recall with the previous topic. So earlier we discussed about the transistor configuration, namely common base, common emitter and common collector. So a transistor contains the two PN junction, emitter base junction and collector base junction. We also know that the forward bias allows the current to flow and the reverse bias current will be blocked, right? So another important concept is the electric field inside the semiconductor. So when the reverse voltage increases, the electric field becomes stronger. So if the voltage exceeds the safer level or the safer limit, then the breakdown occurs. So every transistor has a safe operating limit, and if the device operates beyond the limit, excessive current and heat may damage the transistor. So today's topic of discussion is first we'll look at about the transistor breakdown, types of breakdown, causes, effect, prevention, and then application of breakdown phenomena. So first let's discuss about why do we need to study that breakdown. So understanding breakdown is important because it helps us avoid the transistor damage, ensures safe circuit operation, improves the reliability of the electronic system. So in power electronic, transistor handle high voltage and current. So the designers must know the breakdown limit before designing the circuit. Interestingly, breakdown is not always harmful. In some devices, like Zener diode, breakdown is intentionally used for voltage regulation and the protection circuits. What is breakdown in transistor? It is a condition in which the reverse voltage across a junction exceeds a maximum limit. When this happens, a sudden increase in the current occurs and the junction loses its normal blocking properly. So excessive heat may be generated. So breakdown mainly occurs in the collector base junction because it is reverse biased during the normal transistor operation. If the current is not controlled, a permanent damage may occur and the transistor is being function to fail properly, right? Next, types of breakdown. There are three important types of transistor breakdown: avalanche breakdown, Zener breakdown, thermal breakdown, and each type occurs under the different operating condition. First, avalanche breakdown occurs at the high reverse voltage, whereas Zener breakdown occurs at the low reverse voltage in heavily doped region. Thermal breakdown occurs during the excessive heat generation. Now let us discuss each in detail. Avalanche breakdown. Avalanche breakdown occurs when the reverse voltage becomes very high and due to the strong electric field, the charge carrier gain the high kinetic energy and these carriers collide with the atom and new electron hole pairs are generated. And this repeated process causing multiple multiplication of the current, and that is why it is called avalanche breakdown, and this type is common in lightly doped semiconductor region. Next is the Zener breakdown. Zener breakdown occurs at the low reverse voltage levels. In heavily doped region, the depletion region becomes very thin, a strong electric field is produced, and this field directly breaks the covalent bond and releases the carrier. Avalanche breakdown, it is not similar to the Zener breakdown and it is intentionally used in Zener diode for voltage regulation. Thermal breakdown occurs because of excessive heat. When temperature increases, current gain also produce more heat. And the cycle continues and may finally destroy the transistor. So how could we prevent this, right? So when breakdown occurs, current suddenly increases and the transistor overheats, the device characteristics changes, right? And the entire circuit may fail. So the prevention could be proper biasing technique, current limiting resistors, heat sinks for cooling, operating within the safe operating area zone, and protection like Zener diodes and fuses. Advantages and application. Some applications are voltage regulation using the Zener effect, surge protection circuit, controlled switching devices, protective electronic system. So Zener diode maintain the constant voltage in power supply by operating in breakdown region safety. So let's summarize. BJT is a current controlled device. Proper biasing is essential for the normal operation. A quick quiz over here. Breakdown in transistor generally occurs due to the excessive voltage or current. Avalanche breakdown is characterized by a sudden increasing current. These are the references I have taken. Thank you. Kindly watch my upcoming video. Thank you.